Hi everyone. In this video, we're going to be doing A-level maths 9709 paper 53, probability and statistics 1, May June 2025. This paper is 1 hour 15 minutes, so we're going to try to finish this paper within this time limit. So without further ado, let's get started. Okay, so for the first question, we're told that for a set of 40 values of x, it is found that the sum of x minus k is 836, and the sum of x minus k squared is this, where k is a constant. And for the first part, we're told that the mean of these 40 values is 124. We have to find the value of k. Okay, so in order to do this, we can find the sum of x first by multiplying the mean by times 40. So this will give us sigma k. So we get 4960. And this, we can actually rewrite it as this. So this is just x1 plus x2 all the way to x40 minus k1, k2 all the way to k40. And k1, k2, k40, they're all the same. It's minused by k 40 times. So this one, we can just rewrite this x1 to x40, that's the sigma k, sigma x, and then this is minus 40k. Okay, so this is how we can rewrite this expression that we're given in there. Okay, so now let's substitute the sigma x we found and equate it to what we've been given at the beginning. So 836.0. Now we can make 40k the subject. So that's just 4960 minus 836. Type into your calculator, you will get 4124. And then you'll get k equals to 103.1. So this is our final answer for this part. Let's head on to the next part. Okay, so for this next part, we're going to have to find the standard deviation of these 40 values of x. Okay, so first of all, let's head on to a formula sheet and look for the formula for standard deviation. Okay, so as you can see, it is right here. We're actually given two formulas. One is this, and one is this. To choose which one you have to use, just check the information that you have been given. So we are given x minus k squared, which is the same as, this. Yeah. So for standard deviation, like even if you minus each value of k, minus each value by a constant k, the standard deviation doesn't change because standard deviation measures the spread of data, like how spread out these all the values of x are. Okay, so if you add or minus the same number to each value of x, the spread is not going to change. So you don't have to change anything to this. You can just use this as it is. So hence we're going to use the second formula because it has sigma x squared. And in our case, we have to use a sigma x minus k squared. So let's write down the formula. So it is square root sigma x minus k squared over n. So n is just 40 minus mean squared in our formula sheet. So this one would just be sigma x minus k mean. So this is the formula we have to use. So as we know, we are not given this, so we should find out the mean. So this would just be this 8360 divided by 40. So we get 29.0. Oh, sorry, I forgot to put squared in here. Let me check one more time. Yep. Okay, and then so now we can start substituting everything. So this is 25410.8 divided by 40 minus 20.9 squared. Type it into your calculator. You would get 14.123 SF. So this is our final answer for this part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that at a large college, all students who study science also study exactly one of art or drama or music. And we're told that 20% of these students study art, 45 study drama, and 35 study music. And for the first part, we're told that 3 students are selected at random from the students who study science. So this is like the students who study science is our population, and we selected 3 students out of the entire population. And we have to find the probability that at least one of these students studies drama. Okay, so if you realize this is actually a binomial distribution of 3, and the probability of success is the probability of the student studying drama. And since 45% study drama, the probability would be 0.45. And how do you know that it's a binomial distribution? Well, we're given like a fixed number of trials in here. And within this number of trials, we have to have like a certain number of successes. So in this case, our trial number is 3, and we have to see like what's the probability that at least one, succeeds. In this case, studies drama. So I hope it's clear that there's a distribution that we have to use. Okay, so P x more than or equals to 1. At least 1 means it can be 1, 2, or 3. And to find this out, we can just subtract 1 from the probability that x equals to 0. So that means the probability that none of the students study drama. Okay, so we're actually using the probability law. So if you want to find the probability of P happening, it's just 1 minus P prime happening. So P prime is the probability of P not happening. Okay, so this would just be so 0 is studying, so it's just 0.45 to the power of 0, and then 1 minus P, which is 0.55 to the power of 3. So type it into your calculator. You would get 6669 over 8,000. Or if you don't want to leave it in this form, you can also just leave it to 3SF. So this is our final answer for this part. Let's head on to the next part. Okay, so for this second part, we're told that 10 students are selected at random from the students who study science. And we have to find the probability that more than 7 study art or music. Okay, so first of all, let's see what's the probability of study art or music. So first we have to know the percentage of students that study art or music. So it's just these two percentages combined. So altogether they give you 55%. And again, if it isn't obvious by now, this again follows a binomial distribution where the sample space is 10 because we chose 10 students. And the probability of success is 20% plus 35%, 55%. So 0.55. Here we want to know the probability of X being more than 7. So more than 7 can mean that X could be close to 8 or X equals to 9 or X equals to 10. So we have to find these three individual probabilities and add them up to find X more than 7. So let's start for Px equals to 8. So to find the probability of a binomial distribution, you just take your sample space n, so 10, choose the X value, which is 8, and you multiply it with your probability of success and raise it to the X value, so in this case is 8, and then you take your 1 minus P, the probability of failure, so 0.45, and you take n minus X. So in this case, 10 minus 8, which is 2. So these two powers, they should add up to 10, okay? Your number of trials. And then for X equals to 9, same procedure, and choose 9 times 0.55 to the power of 9. And since this is 9, the next power should obviously be raised to the power 1. And then finally, 10 choose 10 is just 1. And this is 0.55 to the power of 10. So the next one, 0.45, should be raised to the power of 0, which will give you 1. So you can just leave it like this. Okay? And now just type all this into your calculator. So final answer is 0.0996, the 3SF. So this would be our final answer for this part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that a fair six-sided dice with the faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 3 is obtained. And the number of throws taken is denoted by the random variable x. Okay, so x is basically the number of throws taken to obtain a 3. So for the first part, we have to find the probability of P being Px equals to A. Okay, so first let's determine what distribution X follows. So here we're doing something repeatedly until we get a specific outcome. So if you're doing something repeatedly, like you're doing it repeatedly until you get the first successful outcome of what you want. This is going to be a geometric distribution. And unlike a binomial distribution, there is no like fixed number of tries. You can do it as many times as you have to. So here a parameter would just be the probability of success. So we just have to know the probability of a 3 being obtained. So since it's a fair-sided dice, the probability of obtaining each of the faces is 1 over 6. Because there's 6 sides and there's only one side with 3, so 1 over 6. So here it's going to follow geometric distribution with the probability of success being 1 over 6. Okay, so now we can find px equals to 8. So obviously this would just be, so the first 7 attempts, so x equals to 8 means the previous 7 attempts would be failures and the final 8th attempt would be successful. So this would obviously be 1 over 6 times 1 minus 1 over 6, probability of failure raised to the power 7, since there are 7 failures. I'll just type this into your calculator. Okay, you would get 0.0465 to 3SF. So this would be our final answer for this part. Let's head on to the next part. Okay, so for the second part, we have to find P, the probability that X is less than 9. Okay, so to find this out, let's try to understand what X less than 9 means. So X less than 9 means that you have to get your first successful outcome within less than 9 tries. So the maximum number of tries you can have is 8. So this is actually the same as saying probability of X being equal to more than or equal to 8, since this is a discrete distribution. So to do this, you can use this formula, 1 minus q to the power of 8, where q is the probability of failure. So if you manage to, get your successful outcome within 8 tries, this is completely opposite from not being able to do it at all within 8 tries. So, when you add the probability of failure of 8 times and the probability of getting your successful outcome within 8 tries, it should add up to 1. Again, I'm using this probability formula, so P prime must be equal to 1 minus P, where P prime is the probability of an event not happening and P is the probability of an event happening. So this is the logic behind this formula. Okay, so this would just be 1 over 5 times 5 over 6 to the power of 8. So this is 1 minus 5 over 6 times 8 to the power of 8. You get 0.767 to 3SF. So this is our final answer for this part. And if you can't remember this formula during the exam, you can also just add up the individual probabilities of probability of X equals to 1 all the way to the probability of X equals to 8. So you can just add up the individual probabilities of each value of X from 1 to 8. That will also work even though it's longer. It's still a valid method. So without further ado, let's head on to the final part. Okay, so for this final part, we have to find the probability that 3 is obtained for the second time before the 6th throw. Okay, so in order to get 3 for the second time, the least number of throws you have to do is 2, and the most that you can do, you can do is 5 in order to get 3 two times, okay? So let's consider the case where you just do 2 throws first. So to get 3 for the second time within 2 throws, your first throw you should obtain a 3 as well as the second throw. So probability for this is just 1/6 squared. Now let's consider the case where you have to do 3 throws in order to get your second 3. So first case is that you can have 3 in the first attempt, 3 in the second attempt. Wait, no. 3 prime and 3 here. Or you can have 3 prime here, 3 here, and 3 in the final attempt. So your final attempt should be the, yeah. Okay, so, okay, for this, it would be, let me check if it's, yep, these are the, yeah, so your second 3 should be on the last attempt. Yep, so this is just 5/6 times 1/6 squared times 2. Right, so this one is just 1/36, and this one is 5/6 times 1/6 squared times 2. 5/108. And then for fourth rows, you can have 3 on the first row, and these 2 throws would be not 3. Final throw would be 3, or you can have 3 in the second attempt, not 3 here, and 3 in the final attempt. Or you can have 3 in the third attempt and 3 in the fourth attempt. So these are the possible values. So probability of this would be 3 times 3 prime, that is 5/6 squared times 1/6 squared. So this is 3/5/6 squared times 1/6 squared. So this is 25/432. And then for the final case, 5 throws, you can have 3 on the first, or 3 on the second, or 3 on the third, or 3 on the fourth. So that's a total of 1, 2, 3, 4. 4 possibilities. So 4 times 5, 5/6 cubed times 1/6 squared. So this would give you, sorry, oh my gosh, 1/6 squared. You will get 125/1944. So just add all these probabilities up, okay? So 1/36 plus 5/108 plus 25/432 plus 125/1944. Okay, this would give you 763/388. or you can also leave it to 3SF as 0.196. So this is our final answer. For this final part, let's head on to the next question. Okay, so in this question, we're told that 84 people attempt a particular puzzle. Times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. Okay, so here we have our cumulative frequency graph. So what this tells us is like the number of people that have completed like within, like let's say 6 minutes. So the number of people who have completed um, in 6 minutes is yeah, number of people who completed in 6 minutes is within it's here. Okay, all right. So for the first part, we have to use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. Okay, so in order to do that, okay, so as I was saying, to read a cumulative frequency graph, you have to know that for like, let's say people who took 6 minutes. So this point represents the people who completed the puzzle in 6 minutes or less. So here, this is 52, 54, okay, 58 people completed the puzzle within 58 minutes or less. So to find the number of people who took between 4 and 7.5 minutes, we're gonna have to find out the people who did it within 7.5 minutes first. So let's look for 7.5 on our x-axis. So this has to be 7.2, 7.4, 7.6. So 7.5 is here. It's a trace along the middle. Okay, so yeah, this is also halfway between 70 and this. So the 62, 64, 66, 68. This is going to be 69. Okay, don't forget to draw your dashed lines because the examiners might mark for your working. Okay, and if possible, please use a ruler to do this dashed marking, and especially if you're required to draw a cumulative frequency graph. Okay, now let's find the number of people that did it in 4 minutes or less. So let's look at here. Okay, again, it is halfway between this point and this point. So, yep, we're gonna label. Okay, so this is like 22, 24. This would be 25. So to find out how many people did it between this interval, you just take the number of people that did it within 7.5 minutes and the number of people that did it within 4 minutes. And this would give you 44 people. Yep. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, on the grid below, we have to draw a box and whisker plot to summarize the information in the cumulative frequency graph. Okay, so in order to draw box and whisker plot, you have to know your maximum and your minimum value, as well as your Q1, Q2, which is also known as your median, and your Q3, which is your 75th percentile, and this is your 25th percentile. So these are the three values that you should know if you're plotting a box and whisker plot. So let me show you how the rough sketch is. So this will be the minimum value, and then this would be your Q1, then this would be Sorry, this would be your Q2. This would be your Q3. And then this one would be your max. So this is the max, sorry, max, minimum. Q1 is the start of the box, and then Q3 is the end, and then in the middle of the box, you'll have Q2. And by the way, the Q2 doesn't necessarily have to be in the middle, it just has to be within the box. Okay, so let's find out our maximum and minimum. So, okay. So the median, so maximum time taken is 2. Minimum time taken is 2, and then maximum is 12. Okay. And then Q1, that is the 25th percentile. So Q1, it would just be 25% times the total frequency 84. So 1 over 4 times 84, you would get 21. So 20, oh my God, 21 position. Oh, position. Okay, so let's look at the 21st position in our cumulative frequency. So 21 position is in between 20 and 22. So this is somewhere here. So this is like 3, 3.2, 3.4, 3.6, 3.8. Okay, so Q1 is 3.8. Oh my goodness. All right. And now Q2, that's the median. So it's just 50% of 84. Q2, it's half times 84, which is 42nd position. So let's take a look at a cumulative frequency graph for 42. So 42 is right above 40. Okay, trace it. You exactly like get at this point right before 5. So that would obviously be 4.8. So Q2 is 4.8 minutes. It's also in minutes. And now Q3 is just 3 over 4 times 84. And that is equal to 63. So if to look at the 63rd position. So Q3 would just be at the 63rd position. So that is 62. Okay, 63 is between here. Okay, so it lines up perfectly in here. So that is 6.2, 6.4, 6.6. Yeah. So Q3 is 6 point. Oh my goodness, sorry. 6.6. So Q3 is 6.6 minutes. And now we're ready to plot our box and whisker. Okay, so first let's define our scale. So since we have all even numbers, let this be 2, 3, 4, 5, 5, 6, 7, 8, oh my, 9, 10, 11, 11, 12. Yep. Yeah, 2 is max and 12 is min. So let's draw 2 here. And by the way, when drawing any like representation of data, please make sure to use a ruler in the exam. And then 12 would be here. Now let's draw Q1. Q1 is 3.8, so 3.8 is right before 4. So this is our Q1, the start of the box. And Q2 is 4.8, which is right before 5. So it's right here. Q3 is 6.6, which is 2 places before 7. So 6.8, 6.6. Okay, and then this is our box. Then the lines connecting the box to the ends of the whisker plot. Okay, so this is our final box and whisker plot. Let's head on to the next question. Recording in progress. Okay, so for this part, sorry, you're supposed to label your axes. So this is supposed to be labeled as time in minutes. Yeah, so this is the small minor mistake that I made. Okay, so always remember to label your axes. So let's head on to the next question. Okay, so we're told that bag A contains 6 marbles, 6 red marbles, 5 blue marbles, and 1 green marble. And bag B contains 5 red marbles and 3 blue marbles. And we're told that a marble is chosen at random from bag A and placed in bag B. And a marble is now chosen at random from bag B. And for the first part, we're supposed to draw a tree diagram to represent this information, giving the probability on each branch. Okay, so for the first one, for the first branch, we're going to, the marble is chosen at random from bag A. So let's write for bag A. So this is bag A. So bag A has 3 possibilities. You can either pick a red marble or a blue marble or a green marble. Okay, so for red, the probability is 6 over 6 plus 5 plus 1. That would give you 12. So 6 over 12, that is just 1/2. And then for blue, that is 5 over 12. And then for green, that's just 1 over 12. Okay. And now for the second branch would be for bag B. So if you chose red, you would only have 2 possibilities, either red or blue. So red, you would have 1 more red, so this would be 6. And obviously your total number would increase from 5 plus 3, which is 8, to 9. So red would be 6 over 9, which is the same as 2/3. And then blue would just be 3 over 9, which is 1/3. And then if you chose blue, you still have only 2 options. Oh, sorry, red and blue. Okay, and then yes, so if you choose red, if you choose blue first, then put it in bag B, your number of red marbles would remain unchanged, but the total number would still be 9. So this would just be 5 over 9. My gosh. And then when you have blue, place it in bag B, you'll have 4 blue marbles. So this would just be 4 over, 9. And lastly, if you choose green, you would have three possibilities. Again, red, blue, and green. So if you choose red, you would still have 5. So this 5 over 9. Choose blue, you'll have 3. So 3 over 9, which is 1/3. And if you, yeah, and then for green, there would only be one green marble. So you would only have 1 over 9. Yep, 1 over 9. Okay, don't forget to label this as, sorry, bag B. Okay, so this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're gonna have to find the probability that both marbles chosen are the same color. Okay, so let's refer back to our tree diagram. So for both marbles to be the same color, both have to be either red or red, red red, or blue blue, or green green. So let's add those probabilities up for red red, sorry, blue blue, and plus green green. So for red red, it's just be 1/2 times 2/3. 1/2 times 2/3, and plus blue blue, which is 5 over 12 times 4 over 9. Okay, so 5 over 12 times 4 over 9, and plus green green, which is 1 over 12 times 1 over 9. So just type this into your calculator. Get 19 over 36. So this is our final answer for this part. Let's head on to the next and final part. Okay, so for this final part, we have to find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is blue. Okay, so this is a question on conditional probability. So first, let's write down the probability in the conditional probability notation. So this is going to be bag A blue, and then dash, which is basically the same as given that bag B blue. All right, so this we can write down as, so you have to recall that for the probability of A to happen, given that B has happened, it's just the probability of A and B happening over the probability of B happening. So we're going to use this formula. So you have to first find out the probability of bag A, B, and bag B. Oh my. B, B. So this basically means that what's the probability that the marble chosen from bag A is blue and the marble chosen from bag B is blue. So basically this is the probability of both marbles being blue. And then this would be over the probability of the marble from bag B being blue. So for the tree diagram, so it can either be red blue or blue blue or green blue. Yeah. So to find the numerator, you just have to take the probability of BB, which we found in our previous part, 5 over 12 times 4 over 9. So 5 over 12 times 4 over 9 divided by the probability that the marble from bag B is blue. So could either be the marble from bag A is red and blue, or both could be blue, or it could be green and blue. So red and blue, that's 1/2 times 1/3. So 1/2 times 1/3. And then you add it because it's a independent event. I mean, yeah. So 1/2 times 1/3. And then for blue is just 5 over 12 times 4 over 9. And then you add it with 1 over 12 times 1/3 for blue. I took all the possibilities. Right. The final answer for this is just type this into your calculator. So you will get 20 over 41 as your final answer. So this is our final answer for this part in question. Let's head on to the next question. Okay, so for this question, we're told that a company sells bags of pasta. The masses of the large bags of pasta are normally distributed with mean 2.50 kg and standard deviation 0.12 kg. And for the first part, we have to find the probability that the mass of pasta in a randomly chosen large bag is less than 2.65 kg. Okay, so here we're gonna let X be the masses of the large bags of pasta. And here X follows the normal distribution with mean 2.50 and variance 0.12 squared. Okay, so we have to find the probability that X is less than 2.65. So to do this, we're gonna have to standardize it by finding our z-score. So to do that, just take your 2.65 and then minus the mean and divide it by the standard deviation. Okay, let's evaluate it. You would get 1.25. So this, you can just write it as a function of phi using the notation in our MF19. Yeah, so this is a normal distribution table. So phi z has to be equal to the probability of z being less than z. So can rewrite this as phi 1.25. So now we're going to find the value of z being equal to 1.25. So these are the first two digits, 1.2, and then 5 is here. So our z value would be 0.8944. So this is going to be 0.8944. Let's double check that. Yep. Then we can rewrite this as just 0.894 to 3SF. 3SF. So this is our final answer for this part. Let's head on to the next part. Okay, so now we're told that a restaurant manager buys 160 of these large bags of pasta. And for this second part, we have to find the number of bags for which you would expect the mass of the pasta to be more than 1.65 standard deviations above the mean. Okay, so all right, so what is 1.65 standard deviations above the mean? So that's actually the definition of our z-score, because if you can see the z-score, you have to minus it from the mu, so you can see how far away it is from the u, and you have to divide it by the standard deviation. So it would tell you how many standard deviations away you are from the mean. So this is the definition of a z-score. So here we are already given our z-score. So you can just write p z more than 1.65. And this is the same as 1 minus p, probability that z is less than or equal to 1.65. And we can rewrite this probability that z is less than or equal to 1.65 as a function of phi 1.65. So let's find out what the value for z equals to 1.65 is. So first two digits is 1.6, and then the second digit is 5. So this is here. So this is the value 0.9505. So 1 minus 0.9505. You would get 1 minus 0.9505. You would get 99 over 2000. But here they're asking for the number of bags and not the probability. So to find that out, just take your probability multiplied by the total number of bags, which is 160. So you would get 7.92, which you can round off to the nearest whole number as 7, or 8 is also fine. So I'm just going to put 7 to the, oh goodness, to the nearest whole number. So this is our final answer for this part. Can either be 7 or 8. Let's head on to the next and final part. Okay, so here we're told that the masses of small bags of pasta sold by the company are normally distributed with mean mu kg and standard deviation sigma kg. And tests show that 77% of these bags have masses greater than 1.26, and 44% have masses less than 1.35 kg. So in this part, we have to find in either order the value of mu and the value of sigma. So we can find the value of mu or sigma first, like whichever we want. So either you can find the value of mu first or the value of sigma first. Okay, first let's let x be the mass of the small bags of pasta. So x follows the normal distribution of mu, comma, variance sigma squared. Okay, so the probability of x being more than 1.26 kg, that is equal to 0.77. Okay, and this is actually just equal to 1 minus probability of x being less than or equal to 1.26. Let's make this probability the subject of our equation. So that's just 1 minus 0.77, which would give you 0.23. Yeah, 0.23. Yeah, so as you can see, the probability of this is less than 0.5. So that means Let's just first standardize it. So Z just be 1.26 minus mu over sigma. This is 0.23. And now let's transform it to a function of phi. So phi 1.26 minus mu over sigma equals to 0.23. Yeah, so as I was saying, the probability in here is actually less than 0.5. So this area is actually to the left of the the mean. Yeah. So this means that our phi value is actually negative. So we can rewrite this as 1 minus phi mu minus 1.26 over sigma equals to 0.23. Yep. Yeah, like we're using this formula here. Phi minus z equals to 1 minus phi z. So this value here is negative. So I made it like positive by factoring out the negative one. So making this a subject, you get phi equals to mu minus 1.26 over sigma as 0.77. Okay, so now you have to use the tables in reverse. Okay, so you have to look for like 0.77 within this whole, value. So the way we do that is we look for the value that is closest to 0.77 and less than 0.77. So 7877. Okay, I found one. So this one. So for this, in order to make it 0.77, you have to add 20. You have to add 27. And we can see that 27 is indeed here. So hence the Z value would be, our value inside phi would be 0.739. 0.739. So we can equate this. So, oh my gosh, sigma 0.739. 0.739. Okay. All right. So this is okay, you know what? Let's make mu the subject. So multiply by sigma, you would get 0. Oh my gosh, 0.739 sigma plus 1.26. This is the first equation. Okay, now let's use the second piece of information that 44% have masses less than 1.35 kg. So here, okay, let's do it here. Be x less than 1.35. Yeah, less than 1.35 is 0.44. Okay. So again, never mind. Let's just standardize it. So Z 1.35 minus mu over sigma 0.44. This would give you a phi of 1.35 minus mu over sigma. You get 0.44. And since again, the probability in here is less than 0.5, this phi value is actually negative. So I'm not going to write this whole thing down again. Just going to straight away factor out -1 and -1 from the probability. And you get 1 minus 0.44. That is 0.56. Yeah. Okay. All right. And now we can form the equation using our normal distribution table. We have to use it in reverse again. So let's look for the value closest to 0.56, but less than 0.56. Okay, found 0.596. To make it 0.56, you just have to add 4, which is here. So hence our value would be 0.151. So this is 0.151. I'll just make mu the subject straight away. So mu would just be multiplied by sigma, both sides of equation, and add 1.35. So this is a second equation. Okay, let's use this space, left side to solve. So let's equate 1 and 2 together. Find sigma first. So 0.739 plus 1.26. You know what? Let's just erase this imaginary line. Equals to 0.151 sigma plus 1.35. So moving sigma to the left-hand side, it'll be 0.739 minus 0.151. You will get 0.588 sigma. Then moving 1.26 to the other side, 1.35 minus 1.26, you get 0.09. Sigma, you just divide both sides by 0.588. You will get 0.588, 15/98. Or you can also express it to 3SF, 0.153. 3SF. So this is, oh my. Okay, let's just draw a line to separate it. So this is our, okay, you know what? Yeah, okay. So, yeah, okay, this is our final answer for sigma. Now let's find mu by substituting into either formula. So mu equals to 0.739 times sigma, which is 15/98 plus 1.26. This would give you 0.739 plus 1.26. You would get 1.37 to 3SF. So this is our two final answers for mu and sigma. Yeah. Yep, these are two final answers. Okay, let's head on to the next question. Okay, so for this final question, we're told that a set of friends consists of 7 men and 4 women, and 3 of these men are brothers, Ali, Ben, and Charlie. And for the first part, we have to find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. Okay, so first of all, let's find the total number of different arrangements with no restrictions. That would just be 7 factorial. And then you minus that with the number of arrangements where Ali and Ben do stand next to each other. So let's draw 7 slots. 5, 6, 7. Let's put Ali and Ben here. Okay, so let's draw Ali and Ben as 1 slot. So now there is 6 slots altogether. So let's write 6 factorial. But it's also possible that, Ben could be here and Ali could be here. So to factor that, you have to multiply by 2 factorial. And then just type this whole expression into your calculator. Sorry. Yeah, you would get 3,600. So this is our final answer for this first part. Let's head on to the next part. Okay, so now we have to find a number of different arrangements of the 7 men and 4 women in a line, in which all the men stand together and all the women stand together. Okay, so let's draw 11 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's draw the men first. 1, 2, 3, 4, 5, 6, 7, and the women. 1, 2, 3, 4. Okay, so the men, they have 7 factorial ways to arrange themselves, and the women, they also have 4 factorial ways to arrange themselves. So we just multiply 7 factorial and 4 factorial. And you also have to realize that this is not the only arrangement possible, that like the men and women, they could switch places. So the women would take up the first 4 slots, and the men would take the 7 remaining slots to the right. So to account for that, you have to multiply by 2 factorial as well. So 7 fact 2 times 7 factorial times 4 factorial, you would get 241,920. So this is the final answer for this part. Let's head on to the next part. Okay, so now we have to find out in how many ways can the 7 men and 4 women be divided into a group of 6, a group of 3, and a group of 2 if there are no restrictions. Okay, so to solve this question, let's first divide all of them into a group of 6. So there's 11 people to choose from. Since there's no restrictions, we can include all of them. And we only want 6 from the 11. So 11 choose 6. And then you multiply by, since you already chose 6 people, you only now have 5 people to choose from. And those 5 people, from those 5 people, you only want to choose 3 to form the group of 3. And finally, you would only have 2 people to form a group of 2. So that's 2 choose 2 or 1. So combining all this together, you would get 4,620. So this is our final answer for this part. Let's head on to the final part. Okay, so for this part, we're told that the 7 men and 4 women are divided at random into a group of 6, a group of 3, and a group of 2. And we have to find the probability that Ali, Ben, and Charlie are all in the same group. Okay, so to do this question, so in order for them to be in the same group, we're gonna have to consider it on a case-by-case basis. So first case is that they're in a group of 6. So you have to find that probability first. So you take the total, wait, Ali, Ben, and Charlie are all in the same group. Okay, so for a group of 6, okay, so Ali, Ben, and Charlie, they would be in the same group. So for a group of 6, 3 spots would have already been filled, so there are 3 more spots to fill. And since Ali, Ben, and Charlie are not part of this, so 11 minus 3, that would be 8. So you would have 8 choose 3 over the total number of possible combinations for a group of 3, which is 11 choose 6. So this is the first probability that they're in a group of 6. And then for the second probability, we're going to have to do 11 choose 3. That's the total number of groups of 3 that's possible. And since we want Ali and Ben Charlie to be there, okay, well, that would be just one group. So 3 choose 3. Like there won't be any more slots to fill up. And then obviously it's not possible for all 3 of them to be in a group of 2. So we'll just ignore that. So type this into your calculator. You would get 7 over 55. So this is our final answer for this part. And we have also come to the end of this question paper. So I hope you found this video helpful, and if you did, please make sure to like, share, and subscribe to this channel for more past paper solving videos of A-level maths and further maths. And if you have any questions or doubts or any suggestions or what paper you would like me to do next, feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.